Let's continue talking about the Wiggers diagram. So part 2 of 3. In this video, we're going to focus on what causes valves to open and close, and we're going to talk about pressure. This shouldn't come as a surprise. Pressure affects those valves opening and closing. And so we've got these 3 outcomes. So again, this is where we're trying to go, and I know that this is in table format and it might not make a lot of sense now, but hopefully it will by the end of the next video. And like I said, we're going to go through each of the phases and tie all of these variables together. So when it comes to valves, pressure gradients determine flow, and really pressure gradients in this case determine whether or not a set of valves is open or closed. Okay, notice that we've got 4 different places where valves open or close. Okay, so down here, the mitral valve, which is an AV valve, closes. The aortic valve opens here. The aortic valve closes here. The mitral valve, or that AV valve, reopens. And then over here, we start the process all over. Okay, and if you look carefully at this figure, every place that I've got an arrow that shows where a valve opens or closes is where an intersection occurs between 2 of the pressure lines. Notice that we've got aortic pressure, which is generally the top line. Then this yellowish line is our atrial pressure, generally on the bottom. And then the ventricular pressure is the one that has the biggest changes. And so all of these will involve ventricular pressure, but it really comes down to what's the relationship of ventricular pressure versus atrial pressure for the AV valve. What's the relationship of ventricular pressure versus aortic pressure for the semilunar valve? So what causes pressure to change inside the ventricle? Well, there's 2 things. If I give you a balloon, how can you increase pressure in the balloon? Well, you can add more air or more water. That will increase pressure. Or you can squeeze the balloon, okay? So in this case, we're going to liken that to the ventricle is actually contracting. So it decreases for the opposite reasons. I can take air out or water out of the balloon, or I can just stop squeezing the balloon and allow it to just go to its whatever shape it wants to go to. The same is true of your ventricle. So we've got aortic, ventricular, and atrial pressures, okay? And so these words are color coordinated with the colors of the pressure curves there, okay? So the diastolic pressure, when you hear about diastolic pressure, you go to the doctor. We're actually talking about pressure in your arteries, so it's the lowest pressure in your arteries. Aorta is an artery. And so systolic pressure is the highest pressure in your arteries, okay? Now notice that during diastole, aortic pressure is higher than ventricular pressure, but during systole, for the most part, ventricular pressure is actually higher than aortic pressure, but just by a little bit. All right, so ventricular pressure changes. We're going to go through each of these phases, talk about why pressure is changing. Okay, so isovolumic contraction. Volume is constant, which means we're not adding more blood or taking blood out of the ventricle. So that's not really going to have an effect on pressure. But since the ventricle itself is contracting, so it's squeezing, the space inside the ventricle is getting smaller. So there's less space for the blood to go, and so it's getting packed together. Then we've got ejection. So during ejection, volume, so blood volume is decreasing, but at the same time, the ventricle is contracting and getting smaller. And so that's why we have an increase in pressure due to that ventricular contraction, but then we have a decrease in pressure because blood is leaving the ventricle. Then we've got isovolumic relaxation. Again, the volume of blood is remaining constant inside the ventricle, so that can't play a role. But the size of the ventricle is getting bigger, okay? So that muscle's relaxing, the chamber, the volume of the chamber, the volume that the chamber can hold is getting bigger, so pressure decreases. And then finally, we've got filling. And so in this case, the heart's not really contracting, it's not really changing its volume so much, or the size of the room, but what's happening is we're adding blood from the atria into the ventricle, and so that's gradually adding pressure. Notice that the pressure changes are biggest when the ventricle is either contracting or relaxing, so that room size is changing, as opposed to when we're filling it up or leaving or having blood leave. So when it comes to these valves opening or closing, as I've alluded to earlier, it has to do with pressure. So the AV valve opens when atrial pressure is greater than ventricular pressure, and I'll show you where that happens in just a moment. Now, just prior to that happening, we're in isovolumic relaxation. So the AV valve has just closed, the aortic valve has just closed, and now the size of the chamber, the size of the ventricle is getting bigger. That reduces pressure inside the ventricle. And so ventricular pressure drops, and we can see that from this sharp decline right here. So we get to this point where ventricular pressure falls below atrial pressure, which allows for that mitral valve or an AV valve to open up. When this happens, blood enters the ventricle from the atria, and we have rapid filling, we have reduced filling, and we have atrial systole, which is not easy. This isn't necessarily easy to see because I don't have the volume curve on here, but you can kind of see changes in pressure. Eventually, atrial pressure will fall below ventricular pressure because we've emptied the atria and we've filled up the ventricle, and so now atrial pressure is less than ventricular pressure, and that AV valve, or in this case, the bicuspid or mitral valve, closes. It's similar with the aortic semilunar valve, only this valve separates the ventricle, the left ventricle, from the aorta. Okay? So the aortic valve closes here, and so when the aortic valve closes, that means that aortic pressure is greater than ventricular pressure. And so we go through this whole cardiac cycle, and eventually, after isovolumic contraction, the aortic valve opens because ventricular pressure now exceeds aortic pressure. And that will continue all through ejection. Once ejection's finished and enough blood has left the ventricle, that aortic valve will close and we go through the whole process again. And so we have isovolumic contraction here, which increases pressure enough to open that aortic valve. And then we've got ejection, where pressure increases and then decreases, ultimately allowing blood to leave, but eventually we get to a point where aortic pressure exceeds ventricular pressure again, and that valve closes. So this leads us to our heart sounds. And so I'll talk about this in class, and I'm sure every one of you that's watching this video has done this. Your parents have asked you to do something, or they've said something, or they say you can't go out with the boy, or you can't go hang out with your friends or whatever, and you storm off to your room, and you want to let your parents know that you are really upset with them. So what do? You slam the door. Okay? That's where these heart sounds come from, when valves close. And so we've got the first heart sound, and this is when the AV valves close. This is also referred to as lub. Heart sounds mark the beginning of one of the isovolumic phases. Okay? And so in this case, lub, or the first heart sound, marks the beginning of isovolumic contraction. Okay? And there are two heart sounds, and so the second one is referred to as dub. In this case, the semilunar valves have closed, and this marks the beginning of isovolumic relaxation. Now, when a set of valves opens, that marks the end of an isovolumic phase and marks the beginning of either filling or ejection, depending on what's going on. So when the aortic semilunar valve opens, that marks the end of isovolumic contraction and the beginning of ejection. When the AV valve opens, that marks the end of isovolumic relaxation and the start of filling. So at the end of this video, can you do these two things? Can you describe what's happening to ventricular pressure, heart sounds, and whether or not valves are open or closed for each phase? And can you tell me why these changes are occurring?